Well, hello there, Algebra 3 students. We are starting our second unit here. It is based about things called exponents and logarithms. So we've been looking at exponents a lot, and we have a lot of properties with exponents. So the exponent actually is this little number up here. This whole thing here is called the power. So it's something we started a long time ago. And what we're going to do in this unit in Algebra 3 is we're going to go into some depth with it. Our first idea, our first lesson with exponents has to do with creating exponential equations. So that's kind of what we're going to start with, creating an exponential equation. We're going to solve for a variable other than time. So the first thing we want you guys to do is we want you to create models. These models are going to be either called growth models or decay models. And what we're going to have you do is we're going to have you use percentages to show increases or decreases. And from there, we're going to solve for some variable other than time. So the first thing we want to make sure we have in our notes is this equation right here. It's A of t. Let's see if I can't enlarge this a little bit here. So A of t, this is the function, equals little a, that is my initial amount, times, and then we have a grouping here. This grouping is 1 plus or minus r. R is the interest rate. And make sure we take that and we divide it by 100, so we convert it to a decimal, because percent means out of 100. The little t is my exponent of this power, the grouping that has an exponent, and that is the number of time periods. This side, A of t, is the amount or final amount after time. We have two types of problems. One type of problem where we're adding, so 1 plus r. We use that for problems that are growing or exponential growth problems, and we use 1 minus r for problems that are decaying or getting smaller. So we have three different problems. I'm going to actually do these problems out of order. So if you would you find this page right here? Okay, let's do this one first. It says if $8,300 is placed in an account, let's change the color of this. Let's get crazy. So if $8,300 is placed in an account with an annual interest rate of 6.5%, how much will be in the account after 14 years to the nearest cent? So if I use the formula from our previous page, amount after time is equal to, let's take our original amount, parentheses, here's where our grouping comes in. Because this particular problem is growing, this is a growth problem, we're going to take 1 plus the interest rate. Now we want to make sure we write that as a decimal. So we divide by 100, and now we're going to use our exponent. Our exponent is time in years. Now once we get it here, it's just all it's about is some order of operations. Just going to make sure we do the grouping here first. This is our grouping. We're going to make sure then we do that exponent next, and then multiply it by the 8,300. You're going to get this decimal. It says to the nearest cent. Our nearest cent is right here. So our final here is this amount. This is an exponential growth problem. Now, we're going to go backwards. We're going to do what we call an exponential decay problem. So this is an example of a decay problem. Initial amount, 730 grams. It's decaying by 27.6% per minute. How much element is remaining after 12 minutes? We want to make sure we put our answer to the nearest tenth. So if we use that same formula, but we're going to modify it a little bit. So the amount after time is equal to the original amount. Let's do our grouping. Now our grouping is going to use a subtraction symbol. And we're still going to put the rate in here. The rate is 27.6 divided by 100. So it's 0.276. And then our exponent is time. In this case, our time is in minutes. So this is going to be to the nearest tenth after 12 minutes. This is a rate per minute. So again, we do that grouping first here. Now we're going to apply that exponent and then multiply it by 730. You can use your calculator for that. Last but not least, the nearest tenth of a gram. This is the nearest tenth. So 15, final for this problem is 15.1 grams. Just make sure that if it's decaying, your final amount is less than your original. If we go back to the other problem, just make sure if it's growing, your final is more than your original. Now there's one other problem. I didn't want to do these in other orders. So this problem also involves growth. It starts with an initial value of $308 in an investment. It does have an interest rate of 2.13%. So it's growing at 2.1%, I'm sorry, but it uses the word continuously. So we're going to use a different formula for that. This is a new formula, and they're going to give that formula for right now. And the formula is V equals P little e, and the exponent here is RT. It's kind of hard to see, is RT. And then it goes on to describe these different values. V is the value of the account after T years. P is the principal, that's the initial amount. E is the base of a natural logarithm. We're going to talk more about that. Our unit is on logarithms, but for right now, what we're going to use for E, if we move down here, it's going to be an irrational number. It's kind of like pi, and we're going to use our calculator to estimate it. It's approximately equal to 2.718281828. So if we're going to do this problem, we're going to use our calculator. I'm going to show you how to estimate that. But the initial setup is just to use this formula right here. So we'll start with the value is your principal. That's the original amount, 308. And then ERT. So what I'm going to do is I'm going to put the E right here. The RT, that's the rate. We'll go back up here. Let's highlight this rate. The rate is 2.1%. 2.1% divided by 100. So that's 0.021 times T. In this particular problem, my T is 18. I think it's 18. Yes, I'm sorry, right here, 18. And now from here on out, what we're going to do is we're going to use our calculator. We're going to try to estimate this right here on our calculator. The first thing you can do is you can multiply the 0.021 times 18 if you'd like. Otherwise, you can just type it all in as one thing. So I'm going to show you how to do that. Give me a second here. So the best way for you to do that is going to be like this. So I'm going to type in 308. Oh, let me clear it. 308 times E. So E, if I could make a note for you guys here, to find E, you're going to use two buttons. Second, this is on your calculator, and then you're going to use the division symbol. Okay, so second division symbol. Let's go back to our calculator. So times second division symbol, that's your E. And then your exponent exponent, let's make that exponent is the rate, 0.021, times the time, which is 18. Now, our calculator is going to estimate E here. It's going to raise it to that power. It's going to multiply it by 308. Okay, it's going to then give it to us like that. We're going to then round that. So we want to round that to our, what does it say? We're going to round to the nearest cent, 449.48. So we'll go to here, 449.48. Final. So you got three types of problems today that involve exponential growth and or decay. Both growth or decay problem, we're going to use the formula from our notes. If it asks for a continuous one, it will give you this formula. It's the PERT formula. Good luck.
And I want to make sure if you see this kind in Delta Math, you know what to do. So this problem says this: a culture of bacteria has an initial population of 8,600 bacteria and doubles every 5 hours. Using this formula, so it's giving us the formula, this is the doubling formula, where P sub T is the population after T hours, again that's the final amount. P sub 0 is the initial population, so that's the starting amount. T is the time in hours, and D is the doubling time. What is the population of bacteria in the culture after 7 hours to the nearest whole number? Okay, so final amount equals initial amount times 2 to the power of T over D. Now, I'm going to just plug my numbers in. This is the initial amount. The initial amount was $8,600 times 2 to the power of T, which is the time in hours, that would be right there, 7, divided by D is the time it takes to double, which was up here, and it was 5. That's what I need to plug in my calculator. So let's go back to my calculator here, clear this out. That would be 8,600 times 2 to the power of, and I'm just going to be careful here. I'm going to put this in parentheses. If you have an older calculator, you would need parentheses in this power. I will hit enter. 22695.5. I'm supposed to round this to the nearest whole number. So that means since after the decimal is a 5, I'm going to round up. This would be 22,696. And what is that? Bacteria? That's how much bacteria there would be after 7 hours. And that is my answer. Be very careful when you do the Delta Math today that you are rounding correctly. If you round incorrectly, you will end up having to do it again. You'll get the wrong answer. So just be careful on that. All right, good luck.